So here's the pre-quiz. Do we have sound? We have sound. 26 or 14.1, right? And the first one gives you this graph, and it's like boop, Betty boop, 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 right? And it says, what's the melting temperature? And you're just going to read this off of here. The melting temperature looks to be 30 degrees Celsius, and the boiling point, somewhat surprisingly, is only 50 degrees Celsius, right? And then the solid phase is here. Right here's solid. Right, here's solid plus liquid, right? Here's liquid plus gas, and here is just the gas. There you go. And then latent heat of vaporization for boiling, right? That's going to be this plateau right here. Okay, so for number 2, what you want to do is read the graph, and I'm looking at that plateau, and it looks to end at, everything is 100 joules, right? So it looks like it ends at 1700. Somebody go, the Q is 1700 minus, and then it began at 1100. So that's 600 joules. Let me just count them. 1, 2, 3, 4, 5, 6. Yeah, 600 joules. That's our Q. Q equals ml, right? So 600 equals, what's our mass? It's right there on the top of the page right there. So 0.218 times L, and then we can divide that, right? We can divide that. That's a division problem. 600 joules divided by 0.218 kilograms is 2752. This is the latent heat of vaporization is 2752.3 joules per kilogram, because I divided joules by kilograms, right? Is that the right answer? Yeah, that's what we got. And then specific heat of the liquid phase. Here's the liquid phase right there. Okay, so I'm going to use MCAT, right? And the liquid phase is from 30 to 50, so that's a delta T of 20. The C is what we're trying to find. The mass is still 0.218. Right, and then I'm looking at the slanty upward line, this guy here, right? I'm counting 1, 2, 3, 400 joules flow in here. Right, this is 400 joules. So you just look side to side. Every square is 100, and so I go from 700 to 1100. That's 400 joules, right? Right, and now I'm going to take 400 divided by this by kilograms in degrees Celsius, and joules divided by kilogram degrees Celsius divided by 0.218. Wow, that was interesting. 218 divided by 20. That's 91.7. So C is 91.7 joules per kilogram degrees Celsius. Right? Now, if you can't remember what the units are for this, notice in problem 4 I give you the units for the constants there, so you can just cheat and look at that. There we go. And then the elusive problem number 4, right? What we have to do is take the, what? A calculator. There you go. Okay, so we're going to heat 3.29 kilograms of water from 21 degrees to steam at 175, right? So that means we got to go from 21 to 100. That's a delta T of 79 degrees, right? And our C is equal to 4186, right? And then we got to go from 100 liquid to 100 gas. Delta T is not relevant. It's just potential energy, right? So our L is going to be 22.6. This one's joules per kilogram degrees Celsius, right? And then we're going to go from 100 to 175 as a gas, right? Our delta T is going to be 75 degrees Celsius, and our C for the gas is, I'm just looking on the sheet. Where is that? There it is, steam. I'm using the steam, so 2010, right?
Stamp your homework.
Yeah, do you want to do that? Stamp everybody's homework? That's wonderful. Okay. And so this calculation looks like this. I'm just going to go MCAT for the liquid plus ML plus MCAT for the gas, right? Okay. And so it's 3.29 times 4186 times 79 plus 3.29 times 22.6 times 10 to the 5th, right? Plus MCAT, so 3.29 times, and then it's this guy here, 2010, and then this is 75 degrees, right? And that is 3.29 times, I'm using parentheses, 41. Because I'm too lazy to type 3.29 all those times. This times everything, right? Okay. You love physics right now. I've got such good hearing, don't I? Okay, Q. So the total Q, you got to add all these guys together. The total Q is, oh, I hate these calculators. 9019350. They couldn't put parentheses in. That's a lot, right? So that's 9.02 times 10 to the 6th joules, right? There you go. And then 5. Number 5 is going to be MCAT equals MCAT. There we go. MCAT is MCAT, so let's see. It is mixed with water, a mystery liquid. Okay, so here's our mystery liquid. All right, we pour that into here. So this is 0.5 kilograms at 45. This is 0.3 kilograms at 22. All right, this is 4186. This stuff is a C. I bet we're looking for the specific heat of that, right? Because it's a mystery liquid. That's the mystery. Okay, so this will be the hot, this will be the cold. Oh, what's the final temperature? These guys go together to 33 degrees. So this goes up to 33, this goes down to 33, right? Okay, so the hot stuff is going to be 0.5 times C that we don't know. The delta T is 45 minus 33, and 45 minus 33 is 12. Is it 12? Right, and then this guy, the water is 0.3 times 4186. And then this delta T from 22 to 33 is 11. Yeah, we'll see if I got it right. Okay, 0.5 times, whoops, that's not what I want to do. I'm going to do the right side, 0.3 times, don't put it in there. Here, put them in the turn-in box. There you go. Okay, so 0.3 times 4186 times 11. And then I'm going to divide by 0.5, divide by 12. And I get 2302 joules per kilogram degrees Celsius. Is that what I got before? Yeah. Yeah, there we go. And then it's rounded on the skill set, or the PreQuiz, it's rounded.